Introducing Distance Room Part 1. The relay's impedance characteristic test is performed in AMT Distance Room. The most important use of this room is to test distance relays and under excitation. Distance relays and under excitation are used to protect the transmission lines and generators respectively. For example, in this video, two MOHO zones are drawn which are displayed in impedance view window. Distance room consists of four main windows including test view, impedance view, ZT diagram, and medium detail view. Shot test, check test, and search test are performed in test view window. In impedance view window, the impedance characteristic of the relay is displayed according to the information entered in test object in terms of X and R, and based on CT and PT secondary values. This is why in this window, the horizontal and vertical axes are named secondary R and secondary X. To view the impedance characteristic based on the primary, you can select primary values from the toolbar. In ZT diagram, the time impedance curve is displayed. If this window is open, along with impedance view and test view windows, by adding a shot on the curve or selecting a point from the table, the location of that point is displayed on ZT curve. In medium detail view window, the characteristics of the shot point and protective zones are displayed. As mentioned before, to test the relay, first it is necessary to enter its information in test object window. Information such as nominal information of the relay, serial number, operation location of the relay, CT and PT characteristics are entered in device block. This section has been thoroughly explained in previous videos, but the main block in this room is distance, by double-clicking on which the distance protection parameters window opens. Two tabs of system settings and zone settings where the setting is entered are available in this window. System Settings tab. The characteristics of the power system are entered in System Settings tab. In System Parameters section, the length of the line is entered in terms of ohm in line length field, while the angle of the line is entered in line angle field. In PT connection field, the installation method of the voltage transformer is selected from among at line and at bus bar states. The installation method of the voltage transformer specifies whether the voltage exists in post-fault, which refers to the time after the fault. If at line option is selected, after switching the key, the input voltage line of the relay equals 0 and the AMT device will not make any voltage into the relay in post-fault. But by selecting at bus bar option, after switching the key, the input voltage line of the relay keeps its nominal value and consequently the AMT device injects the relay with nominal voltage in post-fault. In CT star point field, the direction of the connection is selected from among direction line and direction bus bar states. If the connection is direction line, the current flows from device to the relay. If the relay connection is direction bus bar, it is only enough that the current angle is changed as much as 180 degrees. Then, in tolerance section, time and impedance tolerances are specified. In this field, first the time tolerances are entered in terms of percentage and time in tolerance T relative and tolerance T to absolute respectively. Then, impedance tolerances are entered in tolerance Z relative and tolerance Z absolute fields in terms of percentage and ohms respectively. Grounding factor section. In this section, the grounding factor for phase to ground fault is specified. In phase to ground faults, specifying this number in accordance with the relay algorithm is so important. If this factor is wrong, the calculation of the phase to ground fault will be wrong as well. So, one of the methods mentioned in this section should be selected in accordance with the algorithm used by the relay to calculate the single phase to ground fault. The output voltage and current fault of the device will change in accordance with the selected checkbox in the mode field. Any of these options should be selected considering the type of the relay being tested. The used algorithms can be divided into three groups of type A, type B, and type C in accordance with the different types of relays and algorithms used to calculate the fault impedance. If one of the checkboxes is selected, type A is selected by default. If you do not know the type of algorithm being used by the relay you are testing, it is better to use trial and error method. Mode field. There are various modes to enter the grounding factor values in this section. It is only necessary to select a mode and enter the values accordingly. By entering the grounding factor in this section, the software calculates the impedance for phase to ground fault. If in the relay being tested, the grounding factor is indicated by KL, the KL value should be entered in KL magnitude cell and its angle should be entered in KL angle cell. But if the grounding factor is indicated by RE over RL and XE over XL, you can select this mode and enter the required values in RE over RL and XE over XL fields. RE and XE stand for true and imaginary values of the ground impedance from the relay location to the fault, and RL and XL stand for the true and imaginary values of the line impedance from the relay location to the fault. If in the relay being tested, the ground factor values is indicated by Z0 over Z1, you can select this mode and enter the Z0 over Z1 value and its angle in Z0 over Z1 magnitude and Z0 over Z1 angle fields respectively. Z0 indicates the zero sequence impedance, while Z1 is indicator of the positive sequence impedance of the faulty line. Calculating with RE over RL and XE over XL option. If this option is checked, type B formula are used to calculate the ground factor and its effect on current and voltage produced by the device. In these relays, to calculate the impedance in phase to ground fault, KR and KX factors are used, which are KR equals RE over RL and KX equals XE over XL. Separate arc resistance option. If this option is checked, type C formula are used to calculate the ground factor and its effect on the current and voltage produced by the device. In these relays, to calculate XL, an algorithm similar to type B relay algorithm is used. The only difference is in calculating the true line impedance. As mentioned before, if none of these options are checked, type A formula is used. Impedance in primary values option. In some relays, the characteristic is based on the primary values. But since it is necessary to enter the characteristics in the software based on secondary values so that the device can apply the voltage and current in accordance with the relay characteristic, you should enter the primary values in the software and check impedance in primary values option. By doing so, the values are multiplied by the turns ratio of the current and voltage transformers. LL fault group excludes L1, L2, L3 fault type option. This option is used to separate two-phase fault from three-phase fault. Generally, because of the grounding factor in relays, there is a difference between the characteristic curves of LE and LL faults. But it is possible that in some relays there is also a difference between two-phase and three-phase faults, in which case this option should be used. By checking this option, it is necessary to specify the three-phase fault zones in fault loop column. More explanation on this section will be provided in future videos. Impedance correction 1 ampere over I nominal option is used when the relay's CT is 5 amperes, but in calculations, a 1 ampere CT is used for it. By checking this option, you can use the new turns ratio.